Welcome! This video introduces voltage and current, two fundamental aspects of electrical circuits and circuit theory.
Current is electrical charge moving in one direction, the flow of charge. Negatively charged electrons flowing in conducting or semiconducting materials make an electrical current.
Water flowing in a pipe is a useful analogy to electrical current flow. Continuing the water analogy for electricity, voltage is like water pressure that makes water flow in pipes. Remember that this water analogy is intuitive and not formal. Voltage and pressure have different units.
Voltage is the electrical potential difference that makes current flow. Voltage applied across a conductor makes electrons move through the conductor. To look at electrons in more detail, we look at atoms. Negatively charged electrons orbit the positively charged nucleus of an atom. Electrons in conducting material, like copper, silver, and gold, are not confined to one atom. Rather, electrons in the unfilled outer orbits or shells can move among other atoms in the material. The picture shows a rough and simplistic model of the orbits of a copper atom, element 29 in the periodic table. The outer orbital shell has room for more than one electron. The electron in this outer shell can be shared among other atoms. These are free electrons. The free electrons in the outer orbital shells of an atom can move randomly among other atoms within the material. This simplified picture of a material made up of copper atoms shows black arrows representing random motion of electrons among different copper atoms in the material. When voltage is applied across the material, an electric field in the material pushes electrons in the direction of the electric field, moving the electrons along the material as electrical current. Negative charges are attracted to positive charges, so the electrons move to the right, in the direction of the plus terminal of the applied voltage. The voltage from batteries connected across a load causes current to flow through the load. The load, loosely shown here like a fat brown resistor circuit element, could in practice be a heating element, a light bulb, or an entire appliance like a cell phone. Electrical potential is measured in volts. Voltage is a difference in the electrical potential at two different places, like the top plus side of the two battery series and the bottom negative side of the two batteries. Voltage and electrical potential are analogous to gravitational potential. The two batteries create the electrical potential difference,
and the pump creates a gravitational potential difference between the two water reservoirs. The water in the upper reservoir has more potential energy relative to the earth-ground location than the water in the lower reservoir.
Voltage can drive current through a load and deliver power that can turn a motor.
Similarly, water coming down from higher gravitational potential energy can do work like turn a paddle wheel and generating electricity. By the way, work is a technical term. In physics, work has the same units as energy.
Batteries can charge conductors with positive charge on the upper conductor and negative charge on the lower one. There is an electric field between the separated charges and a potential difference between the two charged conductors. It takes electrical energy to separate these charges. That is what the batteries do.
There is a gravitational field between the upper and lower reservoirs of water. Both reservoirs exert gravitational attraction force on the other. The gravitational field lines were drawn with downward arrows only, reflecting the large Earth gravitational reference.
Although negatively charged electrons flow in metal conductors, the electrical engineering convention is positive current, as if it were positive charges flowing.
This discussion of voltage and current supports understanding of voltage and current sources in Chapter 1 of this book, First and Second Order Circuits and Equations, available from Wiley.
The vertical black arrows in the two lower pictures indicate positive current. Positive current flows out of the positive terminal of batteries and voltage sources, and positive current returns into the negative terminals.
Thank you for watching and learning with us.